各位上海 GSISS 演讲会的来宾，你好，我叫魏卡尔 Karl Weaver。今天下午我会提供这个演讲，希望大家蛮有意思听到我的演讲，谢谢。我将要发表的演讲名为《亚洲人工智能芯片供应链和生成式人工智能智能手机革命》。My name is Karl Weaver. This presentation is called the AI Chip Supply Chain in Asia Pacific and the Gen AI Smartphone Revolution. In Chinese, it's 亚洲人工智能芯片供应链和生成式人工智能智能手机革命. This presentation is about the AI, the artificial intelligence, and also basically what is artificial intelligence. We'll talk about that without any hype, hysteria, or geopolitical issues tonight. And thank you for coming and listening to this presentation. We'll talk about artificial intelligence in terms of the 协议, the AI, the algorithm, the data, 资讯, and also the computational power, 就是电力, 电脑的电力. And that's basically using what AI uses. So let me move forward very quickly. So really what we're talking about is the Gen AI ecosystem, which is going to be the third greatest productivity revolution. The computer, which I entered in working in Taiwan from 1985 until 1992, 7 full years working in the microcomputer manufacturing industry in Taiwan. I rode that until coming back to the United States in 92. And then I jumped into the land mobile radio communications industry, not digital cellular, but analog radio frequencies. And I was selling selling land mobile radio technologies, control and signaling technology for a company called Zetron. At the turn of the century, I jumped into smart antenna companies and eventually the smartphone manufacturing ecosystem. And I rode that up until 2008, and I was dispatched by Gemalto, a French company, to bring contactless mobile NFC payments and mobile device security to China first, and then eventually Taiwan, South Korea, and then it spread to the rest of the world for Gemalto. From 2008 until 2013, came back to America, and then I was involved in working in embedded software security, eSIM, iSIM, IoT, blockchain, and renewable energy resources. And I jumped and I went to go work in Singapore for 2 years, 2021 to 2024, returned, and I jumped into AI. And today's presentation is really about the AI chip supply chain, because that's very, very important. Where does the AI come from? Who makes it? So right now we're in the AI era, and I want to give this presentation to make sure that people understand it's really important. So look at the global human capital for AI competition. It's very competitive. But 50% of all the AI designers, programmers, researchers, 50% come from North and Southeast Asia. So essentially, AI is an Asian technology. However, that Asian talent is mostly working in Silicon Valley for FANG companies, corporations, large FANG companies. But as you can see very clearly, China is racing towards an AI research dominance. Half of those people are Chinese people who are in America. The other half are in Taiwan, China, Singapore, et cetera, et cetera. And the United States is the top company for AI development, but China is actually just behind by not very much. And also Chinese engineers are developing a lot of AI patents that are granted annually. So this is very important to note. AI does not exist without the world combining and cooperating together. Now, I want to talk about DeepSeek, which this is very, very interesting, because DeepSeek, was it a Sputnik moment or an AI art of war? In my humble opinion, it was both. So in terms of this Chinese AI startup with their large language model and their chatbot, they brought some very, very interesting technology, like, for example, a mixture of experts, chain of thought reasoning, reinforced learning, and distillation, which is basically scraping the internet. And basically, these are machine learning processes, and it's actually been quite successful. And in addition, We're using basically NVIDIA's H100 GPUs and to create a lot of the large language model usage and scrape the internet of data. But nevertheless, this is a quite interesting company and it deserves to be recognized for their open AI model. Most of the AI models in the United States are closed. Let's talk about the global ecosystem, 就是整个国际人工智能芯片的产业链的发展。So Taiwan Semiconductor manufactures the AI chips. That's the fab. Most 90% in the world are made in the AI chips come from Taiwan. The AI algorithms come from the United States mostly, but China as well. And then the GPUs are mostly NVIDIA, but designed by NVIDIA, but manufactured by TSMC in Taiwan. China, the data center servers, the cloud data centers, server technology, China manufactures that. Some Taiwanese ODM manufacture that and outsource it to Taiwan. And then there's the rest of Southeast Asia and the rest of Asia for components and materials. So this is not a one-off kind of thing. The whole world is responsible for developing AI. Semiconductor chip ecosystem 所谓的那个半导体芯片产业链. If you understand how this works, it's quite complex. And you have NVIDIA, as you see, number one, and then TSMC number two. But really, what is the semiconductor supply chain? What is the semiconductor chip ecosystem? Well, it consists of IDMs, which are vertically integrated in chip design fabrication. They fabricate the chips. That's Intel and Samsung. They make the chips, but they also design, and they do everything else. So Intel and Samsung actually do everything. Fabless firms like Qualcomm and Broadcom, they contract to foundries like TSMC, and TSMC makes or produces for them. TSMC will produce for anybody as long as you're in their pipeline. So these are kind of the way the semiconductor ecosystem works. Now, Huawei's HiSilicon, HiSi, is a design house for Huawei. And they make the Huawei chips, and they're developing the latest generation of AI chip designs, but they're fabricated by TSMC. But SMIC is also working with Huawei for their Ascend AI chips. So, you have to work with all the foundries and the fabs around the world in order to get your products out into the market. Now, this is the value chain. As you can see, you've got the design side of semiconductor chips, then you've got the actual manufacturing side and all the tools and procedures and hardware and software that's needed for manufacturing. And then you've got the actual chip itself, the GPUs, the inference required, and the edge compute for AI. This is all for AI. It's similar to just the regular semiconductor part, but inference is very, very particular to AI. Let's continue. The data center GPU and AI chip competitors, actually quite a few, quite a lot around the world. But in general, everybody uses NVIDIA's GPUs. They're the most expensive and they're the most profitable and they're the most powerful on the planet. But in terms of competition, it's important, it's healthy to have competition all over the world. So you can see the United States plays a role. England plays a role. Even Israel plays a role. China plays a huge role. Taiwan, of course, plays a role. South Korea, Japan. And it's really important that you have a global supply chain. That's important for competition. Taiwan is the hub for semiconductor chip manufacturing. 90% of all the AI chips come out of Taiwan. This is very, very important. It's a fact. It's home to TSMC, 台积电，全球最大的半导体制造厂 and they lead with 5 and 3 nanometer chips. Soon, maybe 1 nanometer. My guess is photonics will play a role in the future of getting it down to even lower. They have strategic partnerships with NVIDIA, AMD, Apple, Google, Samsung, not Samsung, but almost everybody else, including Chinese companies, mainland Chinese companies. The United States, of course, controls the algorithms, the AI algorithms and the GPU design with NVIDIA. And OpenAI is, of course, is the largest with the algorithms and large language models and their chatbot. Google is not too far behind, and there are also many others, Anthropic, Claude, etc. NVIDIA's role is really designing the cutting edge GPUs for the AI processing, but they don't make it. It's made by TSMC in Taiwan. So basically, everybody collaborates with TSMC. Even Intel collaborates with TSMC. This is actually a fact. Now, China is very interesting because they make the data center, the cloud, and server OEM manufacturing for cloud data center servers. So Inspur is one of the hardware manufacturers, but there are others. And there's also Taiwanese ODMs who design, but then they manufacture in China. So China has dominance in cloud and data center server production. Alibaba Cloud, Tencent Cloud, Huawei Cloud. And they are key players supply for the AI infrastructure deployment. So China is very, very important. Taiwan is important. The United States is important. And of course, other countries. Now, if you see this row of servers, this is a data farm. And basically, it's a farm of data servers. Now, cloud computing is based on massive data centers powered by sprawling servers, server farms all over the world. Here's a close-up, but they're really all over the world. And the United States has about 5,000 plus. China has about 450. The American data centers are all over the world, including the United States. And China, mostly Asia, mostly. And there are servers. These servers are key demand drivers for AI chips. You need the AI chips and the AI data center servers to train large language models for your AI algorithms. So it's very, very important. And Huawei is key a vendor, and they are predicting that 97% of companies involved in AI will have AI in the cloud. It makes perfect sense. Elon Musk is building an AI data center in Tennessee. So as you can see, the AI chip landscape from cloud providers, you've got AWS, Amazon Web Services, Google, Microsoft, IBM, NVIDIA, Alibaba, and others. And actually, it's really only a few, though, that actually control the compute and the demographics. And as you can see here, three American companies and three Chinese companies. And that's quite important. And you can see here also where these are information. This information came from Oxford. You can see where the companies are based. In China, most of the companies are based in China, and they serve certain global South countries. In America, it's really all over the world except China, because I don't think China allows American data centers. But otherwise, you can see the situation. Let's move forward. Now, it's important to understand cloud AI and AI at the edge. AI occurs in two places, either in the cloud through the data center server or at the edge on the cellular IoT module for IoT products, smart data logging dongle type products, or even Tesla vehicles, or in the smartphone, in the mobile apps processor， 所有的那个手机的那个移动应用处理器芯片内。So that's where it occurs, either at the cloud AI servers or at the edge, where there's a GPU and the mobile apps processor chip, but very, very limited power, low power, to create inference to create these solutions that you need for audio, video, and creating tokens for all of your data. So it's important to note that key AI chip components are the memory in an AI chip, the NPU, neural processing unit, the GPU, graphics processing unit, and then the CPU. These are key components. Inference is really the future of AI at the edge. And so you see companies like Huawei and Apple trying to produce their smartphones with AI intelligence to create all kinds of cool user experiences and cool content, whether it's audio or video or data, at the edge. And that makes perfect sense. real-time AI processing. It reduces cloud costs. You want to basically send as least data up to the cloud as possible because it's very expensive, but you want that data to be the most pertinent. So you have to take the raw data and slice and dice it to make sure you've got only the most pertinent data going into the cloud. And that's what the AI is used for in the mobile apps processor chip or the cellular IoT module for IoT applications. So as I mentioned, real-time AI, low costs, better privacy, no doubt, energy efficient, helps the battery life, and then it's scalability. Let me move forward. So China's AI crouching tigers and hidden dragons. So 卧虎藏龙, that's of course a movie, but I thought this was appropriate. China has 4 dragons, 4个小龙, huh? 4个技术小龙. These 4 dragons are focused on facial and image recognition, and also 6个老虎, 6 tigers focused on large language models and 生成式, so generative AI. So this is important. China is moving ahead with its crouching tigers and its hidden dragons. So that's very, very interesting. Now let's talk about custom AI chips. So data center servers need the customization, and they're all investing millions of dollars in these GPUs at the data centers. And actually, they're designing like Amazon, AMD, Google, Intel, Microsoft, NVIDIA. They're all designing the GPUs for their data centers, very customized. And of course, NVIDIA's H100, the most powerful, the most expensive, the most interesting GPU out there in the market. Not easy to find. You can find them at various data centers. That's where you buy them for data centers. But they are restricted in certain countries. And the key is to understand that you use that AI chips are used for training. So an AI model is fed millions of examples of a particular topic, data, and it learns. It's like a child learning something. And then it uses the inference from what it learns, its database of learning, and then it allows you to generate various types of content. And that is called inference. And the cost is critical to the value of the training model. So garbage in, garbage out for the language model will not help your inference. But if it's good, if it's good large language model, the inference will also be even better and less hallucinations. Let me move forward. The integrated supply chain across Asia Pacific. You've got South Korea, you've got Samsung, SK Hynix, but also Micron. But Micron is actually manufacturing in Taiwan, but they've committed to bring 60% of their manufacturing to reshore 60% of their manufacturing to New York, and also some perhaps to Boise, Idaho. Now Japan makes the photoresists and also the silicon wafers. So that's actually very, very interesting. So there's no one company that dominates this entire AI supply chain. There are challenges, of course, geopolitical tensions between the chip wars, the tariffs between the US and China. Everybody knows about that. And there are also supply chain risks with all of this information and also these tariffs. You don't know when to import, what to import. It's challenging. But I feel that there are opportunities and strengthened partnerships between the US and China. 我能够确定我们能够合作. And also regional diversification. So, China and America, they're putting data centers all over Southeast Asia. Singapore is a key place for data centers because they have the technology and the know-how to make those data centers most efficient. They also have a carbon tax, so they're making 100% sure that those data centers aren't emitting too much CO2 emissions, because data centers emit the most CO2 emissions in the world, not airplanes and not cars. So there's a balancing competition and collaboration for AI growth. It has to happen if you want AI to grow. So the future of AI chip supply chain, Taiwan's always going to play the critical role for manufacturing of the AI chips. The US, the hub for AI innovation. The US FANG companies, they say to China and India, bring your AI knowledge, bring your wealth knowledge, your thought leadership, bring it all to America, and we will employ you. Also for the GPUs, we design them in America with NVIDIA. But China has a dominance in the data center server technology, and China's also distributed all throughout Southeast Asia, including Singapore. So really, we need partnerships here between the United States, China, and the rest of the world. We all need to partner because actually it's too important for the environment not to work together. It's too important. So, but there are environmental costs, which I want to talk about. So training and deploying large language models, they come with lots of climate risks, such as the massive energy and power requirements. That's not just for the AI models and the data center servers. That's for any semiconductor chip manufacturing, and they go hand in hand. So you've got growing emissions from electronic waste. That's at the data center. That's also at the semiconductor manufacturing facility. But mostly the data centers emit lots of CO2 emissions, lots of heat, and they need lots of water and power to run efficiently. Just one GPU, one chat GPU query could be 50 to 90 times more energy than a Google search. So you can see all the energy requirements required. If you look at the slide right here, the training and the AI model compared to a car, compared to an airplane, well, it seems very, very obvious here that we have a problem. Houston or Arizona, we have a problem. Now, cloud data centers are the main culprits because they emit the most CO2 emissions. But I believe that we can work on this by providing renewable energy to where the cloud data centers are located. Let me move forward. So AI does have a looming climate cost energy demand. Energy demands are surging and for the data center race. It's a race, but it really shouldn't be because we need to regenerate our planet. Everybody lives on this planet. If we don't have enough oxygen, none of us survive. Actually, maybe the AI robots are the only ones survive because they don't need to breathe oxygen. So you think about this. Electric energy demands from Asia Pacific are exploding. The data centers are power hungry. The whole world needs to pay attention to this as you're having your healthy competition. That's all I want to say. There's another interesting thing going on, which is an evolving investment location for Chinese firms to think about setting up cutting-edge AI chip R&D in the United States, because or even manufacturing. Once you're in the United States, then you don't have to worry about these tariffs. And Chinese companies are very innovative, and Chinese companies are also going global and doing lots of investment. I say go to Arizona. I say go to Arizona or Texas and set up an R&D center to be close to the semiconductor chip manufacturing, either in Texas or in Arizona. And, SoftBank's Masa-san, he is proposing a $1 trillion AI and robotics industry hub in Arizona. China is leading in robotics and competing with, let's say, Boston Robotics. China has lots of robotics technology, and you go to Beijing 首都国际机场，你会看到那个机器人。你到任何中国大的那个饭店，你就会看到机器人，他会送给你水果。So that's real. I experienced all that. So partnering with TSMC, I think, is very, very important because China partners with TSMC anyway, whether it's Taiwan, whether it's China, where they have I think a packaging facility, or even Texas. We need to all cooperate. So this is my humble opinion. Chinese companies will come to the United States to set up manufacturing or R&D. Now, 我们现在开始提到那个就是生成式人工智能智能手机革命 the Gen AI smartphone revolution, I call it, because it is a revolution. Let me move forward. So top Gen AI enabled smartphones, Samsung makes a few, Google Pixel, which is really their design came out of Taiwan, actually, HTC, just to be honest. Apple, Huawei, Honor, which is spun out from Huawei, and also Xiaomi, right? So these are the main companies, and they're all developing AI technology in their smartphones. Makes perfect sense. Let me move forward. Now, but there's an issue with open and closed source LLM. China has DeepSeek is a key company. Quinn from Alibaba, Doubao, Kimu, GML, Wudao, a bunch of these companies. Now, the major 就是中国的智能手机厂商，他们现在都是用 AI. Of course, Huawei uses Pangu, and Apple kind of has a problem because their Apple Intelligence AI cannot be used inside China. So this is a problem. So I think they're going to partner with Alibaba Quinn, probably. That's what I hear. The Gen AI chatbots and smart and market share. You've got the Gen AI chatbots, a bunch of them. You've got DeepSeek, which came out only this year, and tremendous growth. But you've got ChatGPT, which is really the whole world is using right now. And actually, chatbots are growing all over the world. And ask any student in high school, are you using ChatGPT? You already know the answer. Let me move forward. Apple versus Huawei for Gen AI chip solutions. Apple Intelligence actually uses the Apple A17 and the A18 Pro chips to generate the AI inference at the edge of their mobile apps processor chip. 就是苹果手机就是使用那个A18那个芯片，关于那个 inference，关于那个制造那个人工智能的芯片。But Huawei Mate actually smartphone for Ascend, 他们是用那个 Ascend 的那个人工智能的芯片, and that's quite powerful, I hear. And actually, SMIC is also manufacturing some of those. So Huawei uses HiSilicon for the design, but they use SMIC for the manufacture. But also Huawei is using HTC as well. And Huawei has developed their own Harmony OS. And really, Huawei has had to do these things in order to maintain its prominence. They've developed their own OS. They've developed their own chip designs. So Huawei is a very key company. The key here is that Gen AI smartphones are growing in the market. Every single smartphone will have generative AI or its AI intelligence by 2027. This is just a fact. The evolution of AI smartphones, though, well, what did it start with? Predictive text. Siri. Siri was so weak, but now it's trying to get on steroids. But anyway, you have now real-time image recognition using AI for things like payment, security, biometrics. It's powered by AI chips, but it also uses neural engines and hexagon GPSs and efficient models like MobileNet and TinyML. All of this technology is using ML, machine learning, and also neural networks. Neural networks try to emulate the human brain. So we humans still have value. Our brain is of value. Now, robust software ecosystems also, it's migrating to use TensorFlow Lite and Core ML. Machine learning. Teach your kids machine learning. Now, let's talk about applications. 所有的人工智能手机的那个应用, camera and imaging. This will spit out better images if you ask it to from you taking a photo. It will also be able to use personal assistants like agentics in order to give you all kinds of personal user advancements and tools to help you. Security, facial recognition for mobile payment, facial recognition for online verification, authentication, and it's very, very important for that. So security is key. Also, augmented reality and gaming, these are also key. Now, some of the key drivers for the growth of this Gen AI are edge computing, your smartphone, and also IoT devices, your Tesla vehicle. An EV is a smartphone on steroids, on wheels, but also on steroids. The user demand for a smartphone that's going to talk to you, that's going to tell you if you're happy, or know if you're happy, or if you're going to have a heart attack, all these things. Your smartphone has the intelligence right now to do that. And also the chip costs are going down, so it's going to be much more affordable. It has to. Here are the challenges, though. Processing power and energy consumption, they're constrained right now, especially on the edge with smartphones and IoT devices. Privacy concerns over the device data processing. Who owns this data when you're scraping the internet? Are you going to have IP issues? Are you going to have lawsuits? I think yes. Now, balancing the model complexity with real-time performance. It's very complex. You want to make sure you have the best return on investment when utilizing the tools of these AI smartphones. I list some of the features here for the Apple line. The future of generative AI on smartphones, real-time AI, hyper-personalization, tailored experiences. Your AI agents or agentics will be able to do many, many things for you if you ask it to. Health monitoring, especially older citizens. AI, your smartphone will be able to really be the replacement for your dog in many instances. Dog is man's best friend. All Chinese people and American people, we love dogs. Some like cats too. Your smartphone will attempt to be your best friend. That will be AI technology. It's also AI-driven innovation, especially in smart manufacturing. AI will help in medicine and all kinds of technologies. That is my presentation. My name is Karl Weaver. 我的中文名称魏卡尔。我的公司我的顾问叫美国新港科技 Newport Technologies was my consulting. I want to thank you very much for listening to my presentation this morning there in Shanghai. I'm in Seattle. I'm not in Hawaii. That's just the background. I'm actually here in Seattle. If you are interested to talk to me, you have my email there. I'm on WeChat. 我在微信 WhatsApp 整个那个 chat app 都可以跟我联络. And I have my web page, and I also have my YouTube channel. And you can reach me if you have questions, if you have a project you need my assistance on, dealing with the United States, dealing with Taiwan, dealing with Singapore, dealing with China, I can help you. I thank you very much for your time. Have a good day and enjoy this fantastic GSISS conference in the Zhangjiang Science Park in Shanghai. Thank you very much.